Hey guys, welcome back. In this note, we're going to be covering polynomial expressions. Hey guys, and welcome back. This is Franck, and today we are going to be talking about polynomial expressions and how to recognize them. And the easiest way to go about this is just to show you some examples. So let's start with the first one. The first example here is going to be 5x to the power of 4 plus 3x squared minus 2x plus 7. Now, this is a polynomial, and I'm going to tell you later on what makes a polynomial a polynomial. But for now, let's just dive into this one and break it down into pieces to see what makes it up. So, like any algebraic expression, this polynomial is made out of terms. Remember that terms are just algebraic expressions that are separated by pluses and minuses. So in this particular one here, you're going to have 4 different terms making up this polynomial. The first one is going to be 5x to the power of 4, and then 3x squared, and then negative 2x, and then plus 7. Now, every single term here have what you call a coefficient and a degree. So let's start with the first one here. A coefficient is always going to be the number that's sitting together with the variable. And so you have 5 here. And then the degree is always going to be the power that is sitting on top of the variable. So in this case, you have 4. The next term here has for coefficient 3, and the degree is going to be 2. The next one has for coefficient negative 2, and the degree is going to be 1. And the last one here is a particular one because it does not have any variable attached to him. And so this is what you call a constant, because technically this right here is the same thing as writing 7x to the power of 0. And so we know that every number or every variable to the power of 0 is equal to 1, except of course for 0 itself. And so for this last one, the coefficient for this term is going to be 7, and the degree is going to be 0. Now, these together make up the polynomial, and this is going to be a polynomial in x because x is the only variable you can find in there. And so for a polynomial, you would have what they call a leading term. The leading term is going to be the term that has the highest degree. In this case, it's going to be 5x to the power of 4. And so for this leading term, the leading coefficient for the polynomial is going to be 5, and the degree of the polynomial is going to be the degree of the leading term, which in this case is going to be 4. Now I know that you can also build a polynomial using multiple variables. Let's see an example. Our second example here is going to be 7x squared y to the power of 1 minus 5x cubed y squared minus 2y squared plus 3x minus 8. This particular polynomial has 5 terms. And let's start with the first one here. For the first one here, the coefficient is going to be, again, still the number that's sitting in front of the variables. This is going to be 7. But the degree here is going to be a little bit different. So the degree of this particular term is going to be the sum of all the exponents or power sitting on top of the variables. So you're going to have 2 here sitting on top of x, and then you're going to have 1 sitting on top of y. So the degree for this term is going to be 2 plus 1, which is going to be 3. Our next term is going to have a coefficient of negative 5, and the degree is going to be, of course, 3 plus 2, which is going to be 5. Next, it's going to have a coefficient of negative 2, and a degree of 2. Next coefficient is 3, degree is 1, and as usual, the negative 8 is a constant, so the coefficient here is negative 8, or the constant is negative 8, and the degree for this guy here is going to be 0. So terms that are sitting by themselves without any variables are just called constants. So this particular one here is the polynomial in x and y because you have x and y in the expression. The leading term here is going to be the same as before, is the term with the highest degree. So it's going to be negative 5x cubed y squared. Leading coefficient negative 5, and then degree is going to be 5. Note that this leading term was not found in the front of the polynomial. So this is a common mistake people do sometimes. It's just to say, oh, the leading term is whatever is sitting on the front. But no, that's going to be true when your polynomial is written in standard form. This particular one is not written in standard form, so you have to look for the leading term, right? Standard form is when you write a polynomial from the highest degree term to the lowest degree term. That's a standard form. So that's easy to figure out, oh, this is my leading term, and here's the rest of them. All right, so what makes the polynomial a polynomial? The reason why these two are polynomial is simple. It's because all the degrees sitting on top of all the variables individually are natural number, and that's all that makes a polynomial. Okay? That means, consequently, that you cannot have powers that are decimal or negative. You cannot have a variable with natural power sitting on the denominator, and all the coefficient can be anything you want. Coefficient can be real numbers, so they can be square root, they can be rational, irrational, they can be decimal, negative, it doesn't matter. The only restriction here is going to be on the degree of the individual variables making up the polynomial or making up the expression. So let's look at some examples here and see if we got it. First example here is going to be x cubed plus 4x squared plus 1. Okay, I'm going to give you about 10 seconds here to figure this one out. Or not, I'm just kidding. I mean, if you need some time to figure it out, just hit the like button, the pause button, and then subscribe, resume when you're ready to just move on, right? You get what I mean. Okay, let's go. Let's move on. That was more than 10 seconds anyway. Okay, this particular one is going to be a polynomial. We've got it, right? All our powers here are going to be 3, 2, and 0-ish. Okay, so these are all natural powers, and so we are good. And there's no decimal, and there's no denominator. So we're good. This is a polynomial. Okay, next example, we have x to the power of 4 minus 7x to the power of 5 minus x to the power of 3.5 minus square root of x. So if you look at this guy here, is it a polynomial? No, right? Because you have x to the power of 3.5 here, which is no good. And in addition to that, you even have the square root of x here, which is technically x to the power of 1/2. So that's not good either. So you have these two x here with decimal power. So that makes this particular expression not a polynomial. And yeah, that's about it for that one. Not a polynomial at all because of those decimal, decimal exponents. Next example, we are going to have 2x plus 4 divided by x. And so you can see that here, this particular one is actually not a polynomial because you have 2x plus 4 on the top. This is fine. This is a polynomial. And on the bottom, you have just x, which is also a polynomial. But together, when you do a division like that, this becomes a rational expression, not a polynomial anymore. Because if you wanted to put it in standard form, meaning everything on top and, nothing on the denominator, this x on the bottom here is going to be x to the power of negative 1. So technically, this is 2x plus 4 all together times x to the power of negative 1. Which, if you want to simplify it through, you could get 2 x to the power of 1 and x to the power of negative 1 should give you x to the power of 0. And so plus 4x to the power of negative 1. And so this is technically the same thing as writing 2 plus 4x to the power of negative 1. So you can see you have a negative exponent here. One is written in standard form, and that's not good. So this particular one here is not a polynomial expression. Okay, let's move on. Next one. Next one here, we're going to have x y squared minus x to the power of 3 plus y to the power of negative 2 plus the square root of 2. Okay, so what do you think about this one? Yeah, go ahead and think about it. Okay, you're done thinking about it? Good. Now, this is not a polynomial because of the third term here. The third term actually has a negative exponent sitting there, so obviously not good. It's not a polynomial. If you look at the last term here, the constant, the square root of 2, that's okay. That doesn't cause any problem because that's a constant. Constant can be anything they want. It's just the powers on top of the variables there. When you write your polynomial in standard form, should all be natural numbers. So the -2 on top of the y here ruins everything. And so this particular one here is not a polynomial. And so let's move on to the next one. Okay, so this next one here is going to be 5x squared plus 3x minus 4 divided by x to the power of -1. Okay, so this one has a denominator, but it's still going to be a polynomial. Reason why is because if you write this in standard form, meaning everything is in one line, no denominator and everything like that, like we did for example number 3, you're going to see that the x in the denominator here, which has a negative exponent, can go up to become just simple x, right? And so if you multiply these two, you're going to have 5x to the power of 3 plus 3x squared minus 4x. And so this is a nice looking polynomial. So we're done here. This is a very nice straight form. All the powers here, 3, 2, and 1, are all natural numbers, so there's nothing to worry about. This is a polynomial. And let's look at our last example, because that's also going to be important to talk about. Okay, so this last example has a square root of x multiplied by the square root of y plus 1. Now, to figure out if this is a polynomial is, it's not bad, but it's tricky. Because if you wanted to look for the degree, in quotation mark, of this expression, you could say, oh, I'm supposed to sum up all the powers of all the individual variables making up each terms. So you're going to have x to the power of 1/2 here, and y to the power of 1/2 here, then plus 1. And then you could say, oh, x has the power of 1/2, y has the power of 1/2. So together, the degree of this particular term is going to be 1. And so you think, oh, degree of 1. So this is a natural number. We're done, right? No, this actually doesn't work, because to be a polynomial, remember, the degree or the power of each individual variable making up each term of the polynomial needs to be natural numbers. So the fact that x has the power of 1/2 and y has the power of 1/2 here already ruins everything, even before you go into sum them up to figure out, if the final degree for the term is a natural number. So this is not a polynomial because of the square root on the x or the square root on the y. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.